In my previous video, I promised you to start with the hybridization, but because of time and access of materials, I will start with the valence bond theory, and then we shall jump to hybridization later. So, valence bond theory explains the nature and stability of covalent bond. It describes the formation of covalent bonds by overlap of atomic orbitals. So here we have some of the postulates of the valence bond theory, and as you can see here, so in the valence bond theory generally we are talking about the overlapping of atomic orbitals. So first, covalent bond is formed due to overlap of outermost half-filled orbitals of combining atoms. This is the first postulate of the valence bond theory. So it explains about the formation of covalent bonds. That's why we say covalent bonds. They are formed by the overlap of the outermost half-filled orbitals of combining atoms. If you remember our atomic structure and you remember about electronic configuration and orbitals, we say the outermost orbital, outermost shell, means the shell which is ile shell ya nje, wakati outermost orbitals manake kama shell ya nje ni ya tatu, itakuwa na S, itakuwa na P, then itakuwa na D. Kwa outermost orbital itakuwa ni D orbital. So covalent bond is formed by the overlap of the half-filled orbitals, outermost half-filled orbitals of combining atom. Kwa kama hizo outermost orbitals ni D orbital, ndizo ambazo zitacombine. The second postulate, the strength of bond depends on the extent of overlap. So the more the overlap, the stronger the bond. The less the overlap, the weak the bond. Kwa overlap inavyokuwa kubwa, bond yako inakuwa strong, as we shall see later. Then the third postulate, the completely filled orbitals do not take part in bond formation. As we said in the concept of lone pair, that lone pair, they are pair of electrons which are not involved in the normal covalent bond formation. Why? Because they are completely filled orbitals. And the fourth postulate, two half-filled orbitals in bond formation should contain electron with opposite spin. If you remember your atomic structure, you remember about the spin quantum number. And when we talked about spin quantum number, we talked that electron, they can spin in two different directions. So in order to pair the electrons, the two electrons should have two different spin. That is, if one rotates clockwise, another one should rotate anti-clockwise in order for them to overlap and pair. Otherwise, they can't overlap. And from there, we have conditions for an atom to form covalent bond. All of these conditions and postulates, they are asked in questions directly. So you should understand and claim them. Conditions. The first condition is the presence of strong attraction between atoms. In order to form covalent bonds, the atoms should attract. So why there is attraction? Because if one atom has small size and has high electronegativity, because as we shall see later in organic chemistry, that smaller atoms, they have high electronegativity. Electronegativity increases with the decrease in atomic size. So electronegativity and atomic size, they are inversely to each other, inversely proportional. So high electronegativity allow the atom to attract electrons even from the outside or from the neighboring atoms. So attraction of the valence electron of the neighboring atoms, they favor the formation of the covalent bond. And this explains why covalent bond is commonly in nanometers only. Why? Because nanometers always they have high electronegativity. Now the second condition, the first condition was attraction, strong attraction. The second condition is the presence of unimpaired or empty orbitals. As we said before that in order for hybridization to occur, in order for overlap to occur, we should have unimpaired orbitals. But empty orbitals in condition of formation of dative covalent bond. If you were with me in the previous lecture, I am sure you understand about the dative covalent bond. Now unimpaired or empty orbitals act as a loom for shared electron in a covalent bond. But if orbitals employed are two unimpaired orbitals, then normal covalent bond is formed, while employment of empty orbital results to the formation of dative covalent bond. So I'm sure if you were with me in the previous lectures, you understand what I'm talking about. Now, in absence of unimpaired or empty orbital, if all orbitals are full occupied with the electrons, no covalent bond is formed, even if the atoms exert very strong nuclear attraction. This explains why third hydrogen cannot be added to hydrogen gas to form hydrogen molecule which has 3 hydrogen atoms. So that is because there is no room for a new electron either for sharing or even for electron to stay there to form dative covalent bond. Now let's jump to the types of overlapping, as we have already seen postulates of the valence bond theory and the condition. Now let's jump to the types of overlapping. Basically we have many types of overlapping, but we may discuss them. First, we have SS overlap. In SS overlap, as we know that the shape of the s orbitals, they are circular, as you can see here. So in SS overlap, we call it as end-to-end. It can be described as end-to-end overlap. So what is end-to-end overlap? You may understand it later. But here we have two half-filled s orbitals of two combining atoms. They overlap. So for example, you have one hydrogen here and you have another hydrogen, they combine to form a hydrogen molecule. That is SS overlap. Then you have SP overlap. Here is the type of overlap in which they have filled s orbital and have filled p orbital of an atom. They overlap. As you can see, hydrogen and the chlorine have filled orbital and the hydrogen have filled orbital. They overlap to form hydrogen chloride. And then we have PP overlap. Now in PP overlap, we have two types. When we are talking about PP overlap, because here we was talking about the S orbital, which is circular. Here it is SP. P is dumbbell shaped, but S is circular. Now in PP means all two orbitals which are overlapping, they are dumbbell in shape. So here we have two types. We have sideway PP overlap and we have end-to-end overlap. Now what is sideway overlap? In the sideway overlap, we are saying that this overlap occur side to side, perpendicular to the line connecting to the nuclei of atoms. So a good example of the sideway overlap is here. As you can see, this is seen as vertical and this as vertical. Then they combine to form the chlorine. So the combination between these two chlorine atoms to form this chlorine molecule, this is the sideway overlap. The electron density now stays here and here. It is where the electron density stays, the region where the overlap takes place. And now in the end-to-end, as you can see in this diagram, it is very different from the first one. In the end-to-end, this type of overlap in which the orbital overlap end-to-end along connecting lines of nucleus atom. So as you can see here, This lies horizontal and this horizontal, and then they overlap along the line connecting the nucleus of one atom, while here is the perpendicular to the line connecting the nucleus of one atom. So we shall see later what are the effects of the sideway and end-to-end overlap. Now, the two types of covalent bond formed based on the pattern of overlap. We have sigma and then we have pi bond. So, basing on the pattern of overlap, we have two types of bonds formed. And we shall see, as we are going to discuss these types of bond, we shall see which one is a result of which type of overlapping. Now, sigma bond is the strong covalent bond formed by the maximum overlap of two atomic orbitals to make molecular orbital through end-to-end overlap. So sigma bond, they are formed by the end-to-end overlap, and they are stronger as compared to the pi bond. Or in other words, we can say sigma bond is the type of covalent bond which is formed as the result of the end-to-end overlap of hybridized orbital along the line joining the nucleus of one atom. So saying that they join along the line joining the nucleus of one atom, it is similar as you would say the end-to-end overlap. I suggest the first definition because that's many teachers will understand it easier compared to the second definition, because the first definition is more clear, end-to-end overlap, rather than saying the line joining the nucleus of an atom. Some of the teachers, they can't understand you and you may enter in the confusions. So sigma bond have one region electron density on the internuclear axis, as you can as we saw before on the end-to-end overlap. So internuclear axis is the line joining nuclei of two bonded atoms. So if we have two bonded atoms, the sigma bond, they have only one electron density. The intersection region with high electron density formed after overlapping of adjacent atomic orbitals, where covalent bonded electrons are more likely to be found, is known as molecular orbital. So, for example, here in this diagram, here where it is shaded, here is where the electrons they probably occur. So it is called a molecular orbital rather than atomic orbitals, as we discussed in the atomic structure. So there are two different terminologies, molecular orbital and atomic orbital. If you are taught to differentiate them, you should know them by their definition. And this is the definition of the molecular orbital: intersection region with high electron density formed after overlapping of adjacent atomic orbitals, where the covalent bonded electrons are more likely to be found. So sigma bond is formed when two s orbitals overlap, that is s to s overlap, or if s orbital overlap with p orbital, or if two p orbitals overlap by end to end. Hybrid orbital overlap with another atomic orbital, that is hybrid and unhybrid. So here you may say that I don't understand the meaning of hybrid, as we shall discuss in the next part about hybridization. So we understand what is hybridized orbital and what is non or unhybridized orbital. Also, there is a possibility of forming sigma bond when s orbital overlap with d orbital or orbital of another atom end to end. So if there is end to end overlap, the formation or the bond formed is sigma bond. And remember here, sigma bond is formed by hybridized. We have one hybridized and one unhybridized. Now let's jump to pi bond. Pi bond is the weak covalent bond. That's the first weak, formed by minimum overlap of two atomic orbitals, make molecular orbital through the sideway overlap. So this is formed by the sideway overlap. unlike sigma bond. So unlike sigma bond, whose molecular orbital is of one electron density, the molecular orbital of pi bond has two regions of electron density. As you can see in this diagram, we have two regions of electron density in the formation of the pi bond. But there, as we saw in the end-to-end overlap, thus we have only one electron density. Now, pi bond is the bond that is formed as the result of sideway overlap of p orbital perpendicular to the internuclear axis. And this diagram illustrates the formation of the pi bond. So for example, this is our molecule, and this is the ethene molecule having, this is ethane, not ethene, is ethane molecule having one sigma bond here in between, another pi bond here, another pi bond here. So this sigma bond is more stronger because it is formed by the end-to-end overlap of the p orbitals. But these pi bond, they are weak because they are formed by the sideway overlap. Now you can see here why in this diagram they don't show that they have overlapped, and you say they have overlapped. You understand this later as we shall go to discuss. We shall going to discuss this. But as you can see, this was also sigma bond, and this is also sigma bond. So sigma bond is formed by the end-to-end overlap, and pi bond is formed by the sideway overlap. Now there are some few tips to note here. An atom will form pi bond if and only if its atomic size is small enough to enable sideway or lateral overlapping of atomic orbitals. So for example here, if the atomic size of these, for example these are carbon atoms, if the atomic size of these atoms could be very large, they can't form pi bond. Why? Because they can't form sideway overlap. And then another thing, these small size atoms have outermost energy level with a smaller principal quantum number, and therefore smaller atomic orbitals. So in other words, it can be said that orbitals with a lower principal quantum number are smaller in size and hence have greater ability to undergo sideway overlap to form pi bond. So if you don't understand the concept of the principal quantum number, just go and refresh back in the topic of atomic structure. Now this explains why nitrogen can form triple bond. Nitrogen gas can form triple bond, while phosphorus cannot. Why? Because nitrogen is smaller compared to phosphorus. So ability of nitrogen to form triple bond, that means one of the bonds is the sigma bond and two of the bonds they are pi bonds because nitrogen is smaller. Now if you are asked in the exam why nitrogen can form triple bond while phosphorus cannot form, don't wonder because the answers they are here. So also explain why carbon form pi bond while oxygen with oxygen, why carbon form pi bond with oxygen in carbon dioxide, while silicon forms sigma bond only in silicon dioxide. So as you know, silicon and the carbon both they are group 4 elements, but silicon is larger as compared to carbon. That's why it cannot form the pi bonds. As we are going to finish this part of sigma and the pi bond and the valence theory, let's see about the differences between the sigma and the pi bonds. And because some of the teachers they prefer to ask these in exams. First, sigma bond they are formed as a result of end-to-end overlap, while pi bond as a result of sideway overlap. Second, it is stronger due to greater extent of overlap, while pi bond they are weak due to less extent of overlap. Third, can be formed in the absence of pi bond, while pi bond it cannot be formed in the absence of sigma bond. So pi bond is dependent on sigma bond. Sigma bond should be formed first, then pi bond is formed later. Fourth, it can allow rotation of molecule, while pi bond cannot allow or does not allow rotation of molecule. So you may understand it later when we are talking about the rotation of molecule, or if you go to study organic chemistry, you can understand about this concept of rotation of molecule. Fifthly, it is formed by overlap of hybridized orbital, while the pi bond is formed by the sideway overlap of unhybridized orbital. Sixthly, molecular orbital consists of single electron cloud, while the molecular orbital consists of two or double electron cloud. Seventh, stretches along the direction of line joining the atomic, while this it stretches perpendicular. And there are some few tips to note here, that you cannot form multiple bonds with the sigma bond alone. So if we are seeing multiple bond anywhere, that means the first bond is sigma, then the second and third they are pi bond. If there is double bond, one bond is sigma and another is pi. If there is triple bond, one bond is sigma and the other two they are pi. If one of the atoms in the pi bond is rotated, there will be no overlap. So if you rotate one of the atom in the formation of the pi bond formation will not occur. And in sigma bond atoms, in sigma bond, atoms are free to rotate without breaking the bond. And the last tip to note here, the ability to form sigma bond is according to the following order. S, they have great ability to form sigma bond, then px, py, and pz. Thus, s orbital can never form pi bond at all. S orbital can never form pi bond at all. If there is px, py, and pz, then px will form sigma bond, and py and pz will form pi bond. So in the next video we shall discuss about hybridization. Please stay with me and you will understand about the concept of hybridization. Thank you and have nice studies.